Each year in the U.S., about 800,000 people have a stroke. Many are left with limited use of one arm and hand. NPR's John Hamilton reports on a study that shows it's possible to restore a disabled arm by electrically stimulating the spine.
As a teenager, Heather Rendulic liked to run and ride horses. Then, in her early 20s, she had a series of strokes. Rendulic says the last one was the worst.
I woke up and I couldn't move the whole left side of my body.
Surgeons were able to remove the malformed blood vessels in her brain that had caused her strokes, but the damage was done.
It took me almost 2 years to walk on my own unassisted, and I did start moving my affected arm probably about a year in.
But the arm remained impaired. For example, Rendulic could close her hand but not open it. That left her unable to tie her own shoes, open a jar, or chop vegetables.
You don't realize how many things you need two hands for until you only have one good one.
So nearly a decade after her strokes, Rendulic volunteered for a study at the University of Pittsburgh. Researchers there knew that in most people like Rendulic, the brain is still sending signals through the spine to the muscles that control the arm and hand. Marco Capagrosso says the problem is that those signals are very weak.
We wanted to pick up on these weak signals and essentially turn them into functional output so that a person would be able to control their own hand voluntarily.
They plan to do this by delivering pulses of electricity to nerve cells in the spine. The electricity makes these nerve cells more responsive or excitable, which helps signals from the brain get through. And when they did this in animals, Capagrosso says, the team was able to restore arm and hand function.
If you carefully place the electrodes inside the spinal cord, you can direct this excitability, essentially, towards the muscles that you more need, for example, towards the shoulder or towards the hand.
Capagrosso's team was pretty sure the approach would work in people.
But we didn't expect the amount of movement recovery that we observed.
Heather Rendulic was the first person they treated. A surgeon used a large needle to place the electrodes in her spine.
I had wires hanging out of my back, but they had them taped up.
Later, in the lab, researchers turned on the power. Rendulic says the effect was immediate.
I was opening my hand in ways that I haven't in 10 years, and my husband and my mom were with us, and we all were in tears.
A video shows the difference. Elvira Pirandini, another member of the Pittsburgh team, describes Rendulic trying to pick up a can of soup.
And as you can see, she can't really do anything with her hand. But when the stimulation is on, she can reach the soup and she can grab the can and also elevate it.
Pirandini says the treatment also improved something many stroke patients lose, the ability to sense the position of her arm and hand without looking at them.
When the stimulation was on, it was much easier for her to understand where her arm was located in space.
The electrodes were removed from Rendulic and a second patient after the month-long experiment ended. Pirandini says the results, which appear in the journal Nature Medicine, suggest that spinal stimulation could soon reach many more stroke patients.
This is a technology that is used for pain treatment, and there are thousands of people implanted. So the technology is there.
And already approved by the Food and Drug Administration. Dr. Walter Koroshetz directs the National Institute of Neurological Disorders and Stroke, which helped fund the research.
I don't see any deal breakers on the way of getting this to patients.
And Koroshetz says even though this study involved only 2 patients, it hints at a big change in stroke rehabilitation.
I suspect that these people felt something quite profound when they were able to move again. To get that story out, it could put a lot of hope out there for people who are severely disabled after their strokes.
People like Heather Rendulic.